I would like to start with the second topic, automation, chances and challenges.
Yeah, thank you, Peter. Also, two interesting statements at the end of our first topic to think about. Yeah, and as you already mentioned, I like to talk about automation, chances and challenges. Yeah, machine manufacturers today are focusing on more and more automation. And this is also associated with high investment costs. And therefore, I was wondering if or how can smaller labs keep up here? Yeah, because we wanted to know if this development promote also the formation of monopolies, for example.
Yeah, that's I think that's very much fitting with my area, since we are an equipment manufacturer, and of course automation is a big piece in equipment manufacturing and technology. So I believe there's a trend of polarization that we have in the market, and I agree with you that on the one hand we do have more and more large labs that are getting increasingly automated. And for sure, equipment manufacturers, including ourselves, do focus on this group of customers, and we are providing automated solutions for this customer base. But on the other hand, there's also a very successful business model for small labs that deliver fast service and leverage that they are close to their customer. So, for example, that can be groups of opticians or optometrists or small chain retailers, and in those cases, the end customer is the consumer, or it can also be small wholesale labs, in which case the end customer is the eye care professional. And we do develop very new and attractive solutions for this segment also. So we're very well aware of the smaller lab and their needs. And I want to give you an example. We are actually about to launch this coming week a new technology that is called film lamination. And film lamination makes it super easy for small labs to produce hard and AR coding in-house, and cuts the investment to about a third of a standard coding lab. And the way that's being done is that we mass manufacture film discs that carry the hard AR and hydrophobic coding layers. And all the lab then has to do is to laminate this film to the lens. And that can be done with much less expensive equipment, requires very little training of the operator, and it can be done in 15 minutes per pair. So it's a perfect technology for small labs that want to offer fast service and don't have the money to invest into a full-scale coding facility.
Okay, thank you, Andy. What do you think about the topic sustainability? So does more automation in labs also contribute to the to more sustainable production? Also in the sense of economic sustainability, but also ecologically and social. What do you think about that?
I'll be happy to start. Again, since automation is certainly a topic that is very close to us, and yes, I do agree that automation can contribute to more sustainability and often does. So, for example, a smart manufacturing execution system, an MES system, combined with an intelligent conveyor setup, can definitely help to maximize the usage of the machines, which leads to less time that the machines have to be running to process a given lens volume. And that translates into less energy consumption. At the same time, automation can also help to increase yields by eliminating operator errors, right? By eliminating breakage. And higher yield, again, means less energy and water per good lens produced. Because every lens that is broken in the process, of course, is a lens wasted, and you needed energy and water to make it, right? So definitely there is a benefit to automation from a sustainability perspective. On the other hand, you can do many of those things also without automation. So, for example, rethinking the lab's workflow, implementing lean principles, implementing quality principles, training the staff. There's a lot you can do to also improve machine usage and yield without a huge investment. And in fact, we'll be offering a lab consulting program to do just that. As for your point of social sustainability and job security, labs should not automate just to automate, but I think labs should be selective about what they are automating. There are things where a person doing it is still the most efficient and effective way to do something. And operators and their know-how and initiative are key in a production facility. And I don't think that's going to change. Automation should really focus on reducing tasks that are non-value added, repetitive, or non-ergonomic, like unboxing lenses or carrying trays from one machine to the next. But there are other tasks where absolutely, we will need operators in the lab. And I think it's just that tasks are going to shift, that people are going to be doing, like in many other industries as well.
That's true. Okay. François, you want to say something?
Yeah, of course. One of the key things in your lens production is usage of water. There's a need for water in lots of stages of the production, and there are huge amounts of water which is going to the drain like this, and it could be reduced if we have a better understanding about the rinsing capability of this water, the cleaning capability of this water, and this could be done through automation, of course, by measuring some key parameters of the water. I'm pretty sure that we could reduce down to 10% of the actual consumption of the water that is used for the lens production if we have a better understanding and a better control of those parameters. This is one of the key things that has to be addressed in the coming years, because really, and it's even worse, of course, in Asia, when you see those people using lots and lots of what they call pure water tanks for cleaning lenses, but you just don't understand what is rinsing. They believe that rinsing with DI water would give a better quality, but it's not true. I mean, a soap cannot be removed with DI water. And that's those stupid people are doing. I'm sorry, but it's always what comes to my mind when I see the amount of water that they are wasting in those stupid processes. So yeah, this needs really to be addressed in order to be more sustainable, because that's one of the key things that people don't know, that how much water is wasted in our processes. And I'm really looking forward to a better understanding from the lens manufacturers about how important the water is, not only for the quality of the lens, but also for the quality of our future.
Yeah, absolutely right, François. There's definitely a lot of opportunity in recycling water instead of letting water run down the drain. And there are actually quite a few systems available from a technology perspective. Like, for example, there are coolant management systems that recycle that water that is being used in the generators. And at the same time, they separate the swarf from the water, which then makes it easier to compress the swarf, so you have less swarf in the landfill. And they also, I think another trend is going to be that we're going to be looking more at separating the materials that are within the swarf to then be able to recycle it more effective. But I absolutely agree that technological solutions to recycle or reclaim water should be used. They are available, and I think more will become available as we go forward.
Okay, thank you. I want to know more about the social impact. I mean, Andy, you also you already mentioned that there's also a shift from the people working on the machines to go to another place. But as we all know, these are normally not the same people. So the education has to be different. Yeah. Does anybody here has a solution or has an idea on how the society will change?
I don't believe that the ophthalmic industry is trying to educate its technicians in lens design systems that are able to write software that control the machines. I understand that if I were to buy myself, if I were to buy a free-form manufacturing system, I would need to go somewhere to obtain software to run it. And I believe there are few companies which are offering this service, which is good for the companies and it's good for the profession, except that the profession no longer understand how the lens calculations are being made. And I think there's more education necessary for technicians to learn how to write software to run the machinery that they've got.
Okay. Thank you, Ma.
Yeah, maybe another area is also, the machine maintenance. As you have more machines in a lab, those machines, of course, require maintenance. And that is something that I believe, a technician can learn and that can be trained. So, people would, rather than actually manually run a machine, learn how to maintain and keep the machine in top shape. Of course, in the end, I think, you are right that automation will reduce the overall number of operators in a lab. And we got to be clear-eyed about that. But there are still quite a few positions also in the production that can be done by technical people, and machine maintenance would be one good example.
Thank you. I think, José, you wanted to add something?
Yeah, I would like to add to Mo's comment that indeed education is necessary, but we have to take into account that in nowadays in modern time, we need a lot of specialization. Training somebody to design lenses, to design machines, to design processes is hard, and it's a lifetime job. So I think it's difficult to master, for example, in our case, which is lens design, to master lens design, to make people master lens design in such a way that at every lab would be somebody mastering this subject, or, for example, designing the machinery for cutting the lenses. But of course, it's very healthy that they get the best possible overall education about everything about the lens design, so they know what they're buying, what they are making, what they are producing, and what they are selling. And this is at least for IoT, this is a must. This is one of our principles to help customers understanding the lenses. Why are they designed the way they are? I would say it should be the same for the other technologies around lens protection.
Thank you, José. If nobody has to add something else, I like to go to the last question of this topic, number 2. Automation also means monitoring of the whole production process. And I wanted to know how well protected are labs against cyber attacks? Yeah, maybe Andy again.
Sure, yeah, I'll be happy to speak to that a little bit. I mean, of course, yes, protection against cyber attacks is absolutely critical, and now more than ever. Machine manufacturers protect their machine software as good as possible, but honestly, effective protection really requires the labs to implement a comprehensive program for cybersecurity. And what does that mean? It starts with very simple things, right? Like behavioral things of the staff. For example, training employees so they don't open suspicious emails on a work computer, or they don't use the USB port of a machine and plug in their cell phone to charge it. And believe it or not, that has happened. And then, you know, a machine got infected from a virus that was on the employee's cell phone. You know, so those are simple behavioral topics that where labs and really any company needs to work with their employees to make sure they don't do those things. And then, of course, it goes all the way to virus protection software and to firewalls, and really, you know, labs need to engage into these topics and implement them. To your question, are they doing it, or how well protected are they? I think it depends. You know, in general, I think labs are taking these threats to their business continuity more serious and are doing more about it. But you know, it's probably not one level across the industry. But you know, some labs are more proactive about it than others.
Okay, thank you, Andy. Yeah, I would be interested if, yes, Yariv, for example, if smaller companies think about that topic as well.
Well, we have a little bit of a different angle on this cybersecurity thing. Simply saying that our glasses are a connected device. This is a device that can potentially be hacked. So each of the wearers can have their glasses hacked by a hacker, and so we need to think of it as at the user's level, not necessarily at the manufacturing level, which is also, of course, something we should take care of. But while you can, I think the potential damage to having this at the user level is higher, obviously. If someone is using their glasses and all of a sudden they're behaving weirdly because someone else sitting next to them is messing with them. So that's definitely something that we put a lot of thought in, and we design the glasses with this in mind. We have to be aware that if the glasses can connect to a phone, they can be connected in you know, the natural and effective manner, but then they can also need to be protected from being infected from a phone or being connected by a different device that is using Bluetooth or other kind of communication. So yeah, I think this is something that and it also relates, I think, to what Mo mentioned before. I think the more the devices, the technology, the solutions that we're using, either as consumers or as manufacturers, the more they are complex and advanced and get better results, the more difficult it is to understand them intuitively as a person. So you can address big problems at large scale. If you're manufacturing millions of glasses, you can invest in protecting them from a cybersecurity perspective. But then, as the group is smaller, as the solution is addressing less and less people, then you have, and it's much harder to train many people to deal with complex problems. So the way I see it, you have to address the more complex problem at a larger scale with the more experts, with a more trained experts, and then leave as little complexity as possible to the end users, so they don't end up hurting themselves just because they need to do something which is too complicated for them.
Thank you, Yariv. Yeah, for our last topic, okay, Peter, you have to add something?
Yeah, just a small note. Yariv, when you talked about the customer and the hack of the lenses, I thought, I remembered when at Rodenstock, when we tried to fulfill the requirements of the ISO 9001, we talked about individual lenses and how we can control them in the manufacturing process, where nobody looks at the lenses during the process, how we can control them so that because the calculation was individual for the first time, so we had to make sure that the power is accurate, and what would happen if it's not correct? Do people drive against a tree because of this? Are there any accidents possible just because the power is 1 diopter off or half a diopter off? And so with your wonderful sunglasses, if someone is driving very fast and the power is now +2 or so, there could be a problem as well.
That's a very valid point, and that's I mean, the more serious the impact can be, the more perfect the solution need to be to address it. If the impact is not very significant, then we may accept some tolerances or accept some deviation from the design. But then the example that you gave, safety while driving, is 100% like the one leading scenario in our minds. In fact, I remember about 10 or 15 years ago, I was talking to someone in the automotive industry, and there were no smart cars at the time, but they were smarter than I thought, and they said that they handled cybersecurity quite intensively as well. So I think in all of today's devices, you have to address this, and especially if you're using it for vision. So, for example, in our glasses, we designed the lenses. Although the lens can cover the entire field of view, we designed the active area in a way that will always leave a part that is not that cannot be activated. So physically, there is no way to activate that upper part of the glasses. So even if the glasses are hacked, or even in a simpler manner, something goes wrong from a technical perspective, you always have this upper simple part of plain transparent substrate that you can look through. So, but this will be an interesting point. We'll always have to keep in mind that this is a small computer that is connected to our glasses, and whatever can happen to our phones or a computer can now happen, in a sense, to the glasses, and we must take that into account.
Mm-hmm. Okay, thank you. Yeah, I would like to hand over to Peter again for our last topic, future technologies.
Yeah, thank you, Hannah.
Thank you.